Not tomorrow. Wednesday is your test, guys. So we're going to spend today using your doing your review. I'll go over some of the questions with you guys, check some answers if you've already started it, talk about some of the questions. So get that out. Before we start, make sure that you've read any of the announcements and reminders, okay? For you guys, the last day to turn in any missing work for Unit 3 is on Wednesday. It's already set to lock after this period. So after this period ends on Wednesday, you will no longer be able to allow to submit any work for this class.
The username for our Schoology is not our email?
It's your ID number. It's the same way you log into the app. Remember when I showed you guys how to log into the app? Mm-hmm. ID number and then birthday. Oh. But 8 digits for the birthday. 2 month, 2 day, and 4 year. Okay. So for you guys, I guess, like I said, it's Wednesday. The end of the class period that you take the test is the last time to turn in any missing work. You guys have had plenty of time. Okay. Don't ask me for extra credit, and if you haven't done the original credit yet. Okay. There will stay a 0. You make sure that you got to be here on Wednesday for the test if you want to be able to take the test. It's open note. Make sure you gather your things that you need to use for that, including your review. Please make sure that you're submitting your own original work. I shouldn't have to keep sending out emails about copying. Okay, this is happening too much. There were about 15 to 20 assignments for a particular assignment that were all copied and pasted. It's pretty easy for me to tell that, guys. I can see when you copy and paste in Google Docs, right? You do realize that, right?
Well, I haven't copied and pasted.
I know, but do you guys know that that's something that we can see? Okay, when you go to the edit history and it's done in less than 5 minutes, okay, and you have all the same answers word for word, space for space, comma for comma as somebody else, it's super easy to figure out that you copied and pasted it. Okay, please stop doing that. I'm just looking at you guys because y'all are the ones that are here. But this is happening way too much. Okay. Okay. If you guys are at home, you can open up your review by going to Unit 3 and going to the very bottom. I'll show you where it's at. This should be done in your journal. Don't forget that you can use your review for the test. That doesn't mean it's going to be easy. That doesn't mean you shouldn't study. You got to know how to do the process so that you can still do it on the test on Wednesday. Those of you that are at home, open this up, go to your journal, start a new page for review. And remember, I'm giving extra credit for this review. How does that work?
No, you get points on the test, right?
Not points on the test, points on your daily grades, okay? If you do the entire review, it'll raise your overall daily grade between 4 and 5 points. Okay, between 4 and 5 points on your overall daily grade average. So you got to submit it before your test starts on Wednesday. Make sure that you submit it before then. Okay, that's key. Otherwise, it's going to lock and it won't let you submit it. All right, so we're going to start up here. I'm going to close this. You guys know where to find it now at home. And my video is spotlighted so that you should be able to see the board because I'm just going to do this on the board. If I turn off those lights, that glare goes away, but now it's kind of dark. Let's see. Can y'all see the board pretty well? Yeah. All right. Make sure you guys blow up this full screen if you want to be able to see it. Let's do some of this review. Start at the top. Question number 1. Y'all remember how to do the dimensions of a TV?
You divide.
So let's just do number 1 together. All right. Hey, when you do your stuff in your journal, make it nice and easy for me to see. Draw the number and put a circle around it so I can count them up. Because you might do these out of order, especially right now because we're going to go through some of them together, but not all of them. So if you do them out of order, that's fine. But I'm just going to count 1 through 22 to see if you have them all. That's how I'm going to give you your extra credit. So make it easy for me to find as you guys are doing this review. Okay, number 1 says, find the dimensions, the width and the height of a 72-inch HD TV whose screen has an aspect ratio of 2.35 to 1, which is the standard of CinemaScope screens. Round the final answer to the nearest tenth. What's the first thing we should do for a problem like this? Draw a what? Draw a TV. Draw a diagram. Okay, let's draw a little diagram. There's my TV. This is my length. This is my height. And where does the 72 inches come about?
It's like across, right?
It's the diagonal. So this is the 72 inches right here. "72 inches is that diagonal." Can you guys see all this at home? Somebody, thanks, Uriel. Okay, before we can start, we need, well, first of all, what formula are we going to use to solve this type of problem? Well, if I don't know the length and the height, but I do know that the aspect ratio is 2.35 to 1. So it's 2.35 times as long as it is high. So I can set up some variables here, 2.35x, and then this is 1x, okay, using that aspect ratio. So that's what I'm going to do first. I don't know what x's are, but I do know what the hypotenuse of this triangle is. So what formula could I use? Pythagorean Theorem. Okay, a squared plus b squared equals c squared. We know that one of these is a squared, the height is b squared, or the length is a, the height is b, or one way or the other, but the hypotenuse is always c. Okay, so write the formula down so you know where we're starting that out. And then we need to start plugging in. Remember to use parentheses when we make substitutions. For example, 2.35 I'm going to plug in for a, but I'm going to put 2.35x inside parentheses because the squared is going to go on the outside. I'm going to do the same thing for the 1x. I'm going to plug that in for b, and the squared is going to go on the outside. C is my 72. And the only reason I use red because those are my substitutions that I made. I plugged in 2.35x for A, I plugged in 1x for B, I plugged in 72 for C, and now I can solve this problem and figure out what x is. Okay, I got to simplify. Now use your calculator. Get your cell phone calculators out, guys. If you at home, I would download like a scientific calculator, unless the one on your iPhone or Android is already fine enough. Figure out what's 2.35 squared. Who's done that already? Let's do the whole number, right? 5 point what? 5225. And then x squared afterwards. So we have to square the number and we have to square x. That number wasn't irrational. It didn't go on forever. So let's try to keep this as accurate as possible by writing the whole number. What's 1 squared? You don't need a calculator for that. 1. 2? Not 2. 1 times 1 is 1. Okay. 1x squared. And what's 72 squared?
5,184.
5,184. Okay. So only a couple more steps to finish or solve this problem. Next thing, let's combine like terms. These can be combined together into one. 5.5225x squared plus one more x squared is 6.5225x squared. And I'll just bring down equals the 5,184 because I haven't done anything with that yet. Let me see, Aiden. I'm going to be standing mostly for this side because of the camera, so if you need to move to see, it might be a little bit easier since there's only 3 of you. What's my next step?
Divide both sides by the 6.2.
Yeah, divide by the coefficient in front of x, so divide by 6.5225. That cancels. which means that that's going to leave me just with x squared is equal to, put that in the calculator.
794.78.
794 point what?
78.
78. Okay. Last step. Last step. What are we going to do to both sides? How do we get x squared down to x?
Square root.
Square root. Square root. That gives me just x. And use the square root button on your calculator. If you're using an iPhone, you might need to turn it sideways.
Oh, you press the second and then the squared one, right?
It just depends on your. For you, yeah.
Oh,
Yeah, on that one, yeah.
I got 28.191.
28.191. So 28.19.
Well, I got a lot of numbers, but I actually only said the extra one.
Okay. We can do 28.19 for now. Now, our final answer needs to be rounded to the nearest tenth, which is just one decimal place. But this isn't our final answer, okay? This is what x equals. Don't forget that I want to go back and I plug in that for x here to figure out my length and my width. So
now we gotta do it all over with the new number we got.
Yeah. So now we got it. The length is 2.35x and x is 28.19. So the length is 2.35 times 28.19. Round that to the nearest tenth, and that will be your answer for the length.
66.25.
66.25, and it says to the nearest tenth, so 66.3. And this is in inches, so that's how that's how long the TV is. For the height is 1x. Well, do I need to really multiply that out?
No.
By 1? Let's just round it to the nearest tenth. So 28. I'm just gonna write what you were doing so that you know where we got it from, and then 28.2 inches is the nearest tenth for the final answer there. Okay. So there's two parts to that answer, to that question: the length and the width. The dimensions are both the length and the width. Questions on that one? All right. Anybody need it any more at home? All right. I'm going to skip, 2, 3, 4. You can pull up in your notes. Okay. Those are directly, I even wrote on the review where to find it in your notes. Go back to those slides or the videos. Number 5. Let's talk about number 5. It says you have the following tire code. Describe what each number on the code stands for. Draw a diagram if you need help. Wait. So number 5, the code says P. What?
P240 slash 70R16.
Okay. There's 3 numbers on there. Okay. What's the first number represent? That first number is the width of the tire, but in what measurement?
Centimeters.
It's in not centimeters. 240 inches is like the length of this room. What's smaller in centimeters?
Millimeters.
Millimeters.
Oh.
Okay. It's the tire width in millimeters. What about the next number? The 70. This isn't actually a measurement, it is a ratio. It's the ratio of the width to the height of the tire. Now remember that the height of the tire is just the sidewall right here of the tire. So what that means is that this right here is 70% of the width. That's what that's telling you. This right here is 70% of that width. Okay. The last one is the easy one that you should remember, that you should know. What is that? That's the rim size, the rim diameter. And what measurement is that in? Inches, yeah. Okay. So make sure you know those things on a tire so that you can answer a question like the next one.
Wait, and that says, I'm just gonna go forward.
Rim diameter in inches. The ratio of the width to the height. All right, so number 6 says find that circumference of this tire. So I'm going to leave that up there, and let's talk about, there was 4 steps to find the circumference of the tire. Okay. We want to find the circumference so that we know how to calibrate the speedometer and the odometer. But first of all, what's the first step? We have to, if you remember back in your notes or you have your notes out, we need to convert these, since this is in millimeters and this is in inches, let's convert this to inches. Does anybody remember how many millimeters are in 1 inch? Google it real quick if you don't remember.
18.
No.
How many millimeters are in 1 inch?
What?
How many millimeters are in 1 inch?
Oh, wait, no. It's like.
It's 25.4 millimeters.
Okay, 25.4. So my first step, I'm always going to divide the width by 25.4 to get the width of the tire in inches. So tell me do that and tell me what you get.
Say divide them.
Divide 240 by 25.4. How much? 42? 44. So 9.44 inches. You guys also get that? Aiden?
Huh?
Did you also get that?
Oh, I'm still writing the first part.
Yeah, I got that.
Okay.
Well, we don't need it rounded, do we?
Well, the 2 decimal places is good.
Oh.
That's the tire width in inches. Okay, so all I did right there was I just converted this width into inches. Okay, so I'm getting this into inches so that we're using one single measurement. Okay, one measurement. Step 2, I want to find what the height of that sidewall of this tire is so I can find the diameter of the whole tire. I know that this sidewall is 70% of 9.44 inches. How do I find 70% of that?
0.7.
0.7.
Divided by?
Not divided by.
Multiplied.
Multiplied by 9.44. So you always multiply by the decimal to get the percentage of that value. 6 point what?
6.
That's it? What's the next?
0.8.
So 6.61 then, right?
Oh, yeah.
Okay. 6.61 inches. So this is the tire height. Also known as, and you can put this in parentheses if you want to. I'm labeling these so that it's easier for you guys to remember what we're doing. That's the sidewall. So I know that this tire now has 6.61 inches. This is how much this is right here. Okay. Now I want to find the diameter of the whole tire in the next step. If this is 6.61 inches, then this is 6.61 inches down here as well. Okay. So I want to multiply that number by 2 and then add in what? What is this missing part? I know. What is it? The rim. So I want to add it, multiply this by 2, and then add in the rim so I can find the diameter of the whole tire. So step 3, I'm going to put, this is the way I write it. It's 2 times 6.61 plus the 16 inches for the rim.
And that 2 came from where?
Because the sidewall,
Because there's 2 of them.
there's 2 of them when I'm finding the whole way. Yeah. So multiply that out on your calculator.
$29.22.
29.22. Okay. So 29.22 inches. This is the tire diameter. And in order to figure out the circumference is the distance all the way around the tire. Okay. What do I do last with the diameter? I'm going to multiply the diameter by.
The 70. Oh.
Think of geometry. Circle. Diameter times what?
3.
The number that goes on forever.
Pi.
Oh.
Okay. Use the pi button on your calculator, please. Don't use 3.14.
I forgot about geometry.
You forgot about geometry?
Yeah. I don't even know how to pass.
I haven't used geometry since like freshman.
Where's the pi button?
Button that looks like pi.
You press second and then that arrow button.
Second caret.
Oh.
What did you get?
91.797. Oh, so you can be 10?
0.80.
Yeah.
Okay. 91.80 inches. And this is my final answer. This is the circumference of the tire. And I can use that to answer a question like the next one, which most importantly to recalibrate the speedometer and odometer. I wrote that terribly, but that says tire circumference. Okay, it's hot in here. I wish they keep the AC on.
The real one. We image a T, we image a head.
Let's go ahead and do number 7 since it goes along with this problem, which is we decided to change the tire in the previous question to a new tire. And the new tires have a circumference of 85.34 inches. If the speedometer is not recalibrated, how fast will you actually be going if the speedometer reads 75 miles per hour? So there's a little ratio that we need to do. I know the circumference of my original tire, which is this one, and then it gives me the circumference of the new tire. What's the little formula that we use to figure out how fast we're actually going? We have to find a ratio from the difference between the old tire and the new tire. What do we divide? Is it new tire divided by old tire or old tire divided by new tire?
Old tire.
New tire divided by old tire.
It's going to be the new tire divided by the old tire, or the original tire, and then multiply by whatever the speedometer says. Okay? So, what's the circumference of the new tire? It tells you in question 7.
It says 85.34.
Okay, so 85.34 divided by what's the circumference of the old tire?
91.8.
91.80. and then times
75.
75 miles per hour. And let's figure out how fast you're actually going. It says round to the nearest whole number. Round to the nearest whole number. If you're doing this on your cell phone calculator, divide it first, then hit enter, then press times 75 and hit enter. Okay, so 69.72. Now your car is not going to say you're going 69.72 miles per hour. What's your car going to say?
70.
70 miles per hour. Okay, so 70 miles per hour is the answer. So what happened? You got smaller tires, and you're going to be going slower than you actually are going. What happens if you flip that around? If you get bigger tires, what's going to happen? You're going to be going faster than what the speedometer says. Okay, so the opposite of that happens when you switch that around.
Wait, is that actually true?
That's actually true, 100%. That's the whole reason I'm teaching you guys this. So when you change the tire size, you know that you're going to be going faster or slower than what the speedometer says.
Oh, is that why sometimes, like, whenever cops catch you, then, like, your speedometer could say, like, 70, and then, like, you say, oh, yeah, you're going 75.
Well, yeah, if you got different tires on it. Yeah. All right. We've done a couple already. Look at your review. What? Well, Hayden, can you just move to the other side? Because I've got to stay on one side for the people on camera. There's 8 people at home. Thank you. It would just be a lot easier for you to do that. Okay. Does anybody need? Come snap a picture of it real quick or something. Does anybody need number 8?
Let's do it real quick.
Do 8 real quick?
Yeah.
Did you get all of it? Good. Number 8 from the video on election polling talks about margin of error. And it says that a candidate, if an election poll has a candidate winning 53% of the vote with a 5% margin of error, what's the actual percentage range of votes the candidate will receive? Is the candidate a lock to win? Well, if they have right now the polls show that they're going to win with 53% of the vote, but there's a 5% margin of error. That means that the margin of error means that the true percentage could be either 5% above that or 5% below that. So what's 53 minus 5? 48%. And what's 53 plus 5? 58%. So there's the range. I just did that in my head. We all did it in our heads. It can be either 48 to 58% of the vote. The second half of the question says, is the candidate a lock to win? A lock. Like, are they for sure going to win?
It doesn't really say.
Well, if it's as low as 48%, can you win an election with 48% of the vote? No, you got to get a popular vote. You got to be over 50%, right? So right now, this candidate is not for sure to win the election. Now, if you had a candidate that was polling to have 90% of the votes even with an 8% margin of error, so plus or minus, you don't need to write that down. But is that candidate pretty much a lock to win? Yeah. Okay, because even as low as 82%, they're pretty sure that candidate is going to win. Okay, it's the candidates that have these types of polling numbers that we aren't sure of. Okay, but that's where the margin of error comes into play. Most of the polls, even though we look at polls, and if you watch the video on that, even back in 2016, we were like, the polls got it wrong, right? But the polls did count for the margin of error, and the margin of error is where they ended up still being within that rate. We just didn't look at the margin of error very much.
They probably don't even show you, do they?
They do. Like if you pull up polls online, like you can go to CNN or whatever and look at any of their polls. It'll always tell you a margin of error at the bottom in a little small print.
Oh, wow, real small.
Yeah.
But that was just it. You gotta find the margin of error.
Yeah. Mm-hmm.
Oh, okay.
It's easy. Y'all remember how to do the find your average in class, number 9? Can we do that one?
You just add up all your things.
Yeah, I mean, do you guys might as well keep going, right? Okay. And somebody's got a bad connection, I think. I think it's Sunny. Number 9 says, in your first college class, tests are worth 40%. So I'm going to write this down right here. So tests are worth 40%. Project is 25%. Whoops. What's the homework?
Homework is 20.
Homework is 20%.
And the final exam is 15.
And the final exam is 15. Okay, we're going to do the next 2 problems with this because they go together. First of all, you need to find the average within each category first. So there are 4 tests. How do I find my test average?
You add up all these and then you
Divide by 4, right? There's 4 tests. Do that. So find the average in each category first. Find the average in each category first. And then we can actually answer the question that says find the overall grade average. These are not that hard. You just need to know the process.
$78.
78 for tests. Yeah. Okay.
wait, how'd you get that?
Add all the tests and divide it by 4.
If you guys are doing it in your cell phone calculator, even on a regular calculator, add them up together first, hit enter, and then press divide by 4 and hit enter. Otherwise, you're going to get a wrong number because it's going to try to divide that last test grade by 4 if you try to do it in one step, unless you use parentheses. Okay? Did you fix your mistake?
Yeah.
Okay. Add the 2 projects together and divide by 2. What do you get? 88. You guys at home with me? Y'all following along, trying to do it on your own? Yeah. Homework, there's 1, 2, 3, 4, 5, there's 7 homeworks. And I'm going to go ahead and put final exam 57. There was only 1 final, so we already know what that is.
I got 79.
79 for the homework. Okay. So the question for number 9 asks, find the overall grade average. Well, we know the average in each category and we know the percentages. If you remember back from this assignment, which you were supposed to do on your own, this is where we use the weights, the percentages to each one of them. And Hawken answered this earlier. Whenever we find a percentage, we got to convert it to a decimal. So this is what it's going to look like when I set my problem up. Once you write the setup, I know some of you can do this in your calculator in one step, but I'm going to take 40%, which is 0.4 or 0.40, same thing, and I'm going to multiply it by 78. But then I'm also going to add the rest of these as well. So I'm going to take the projects, which is 0.25, times 88. Plus the homeworks, so 0.2 or 0.20 times 79. And then the final exam is plus the 0.15 times 57. Now, for this particular problem, guys, at home especially, if you're using your cell phone, what I would do is I would write down one more step without trying to type it all in the calculator unless you're really good at using all the parentheses. So, for example, I would multiply this and write down what it is. Multiply this and write down what it is. Multiply this, write down what it is, and so on. So you make less mistakes. If you have a graphing calculator, you could probably type it all in one step. But with a cell phone calculator, I would do it in 2 steps. So help me out here, guys. Tell me what each of these actually is.
The first one is
31.2. Okay. So it's going to be 31.2 plus.
I just added them all.
Yeah, I know. That's fine.
22.
22? Okay. $15.8. And then the last one. 8.55. Okay. Again, on the test, if you guys want to do what Hawk did because he has a graphing calculator, just type it in one step. But cell phone calculators, I would do it this way. Okay. If you guys are at home, do it in 2 steps so you make less mistakes. Now just add all these up and that gives you your grade. 77.55. Now, which way is this going to round? Your student portal is not going to say you have a 77.55. This is going to round to 78. So your final answer is you have a 78 in the class. Okay, you have a 78 in the class. Now, number 10 goes along with number 9, so I'm going to go ahead and do that one as well. Number 10 says if you were allowed to retake the final, you got a 57 on it. If you were allowed to retake this, what would you need on the final to get a B in the class? You have a C right now, and you want a B. What's a grade for a B?
80.
80. Okay, so how do we retake? What do we need here to retake it to change this to an 80? That's what question number 9 is asking for.
So you're going to solve for X?
We're going to solve for an X. Now, we know a couple of things. Is the test going to change?
No.
Project going to change?
No.
No. Homework's not going to change. These 3 numbers are going to stay the same. Okay? So, when I first set this up, I'm going to put in 31.2 plus 22 plus 15.8. See how now I've made this next question easier because I had already done that in the previous question. So, those 3 things are not going to change. Now, what is going to change is this 57. I don't know what 57 is going to be now. I got to figure it out. So instead of 57, I'm going to put X. So plus 0.15 X. Don't forget the 0.15 because we need that. That's the weight of it. It's worth 15%. Now, it says in order to get a B. So I want all this to be equal to an 80, right? So we need to set that equal to 80. However, when I do these problems, I do it a little bit different because there's actually a grade that's a little bit lower than 80 that's still a B. What's going to round up to a B?
79.5.
79.5. And if you use 79.5, this gives you the most accurate answer possible. Because 79.5 is still a B. It's going to round up to a B. You'll still have a B. So now we need to solve for X. This is pretty easy. Figure out what this is in the calculator first. Add those 3 numbers up.
69.
69 even?
Sure.
Okay. 69 plus 0.15x is equal to 79.5. 2 steps left to solve this problem. What's the next step?
Subtract 69 from
Subtract
both sides.
69 from both sides. That cancels. So this is 0.15x is equal to 10.5. Last step.
Divide.
Divide both sides by
0.15.
0.15. Just 0.15. This cancels. So x is equal to
70.
70 even?
70 even.
7, perfect. So if I were to retake my final, I would need a 70 to get a B in the class. Okay. If you wanted to figure out what you need to get an A in the class, we change the 79.5 to 89.5. Right? Might be impossible at that point because none of these are even A's. So you'd have to do the work, math, to figure it out. Okay. Should we keep going on some of these worked out problems?
Yeah.
It's all coming back to you now, right?
Yeah.
Well, you guys at home have any questions? There's 7 of y'all there today. Jacqueline, I haven't seen you in a while. Okay. Do y'all need this up any longer? Man, I wish the AC would kick on.
They should at least let the second story windows open.
Second story?
Yeah.
Why the second story?
Because what if it's hot?
But why not the first story?
Because it's a safety hazard.
You don't think it's more of a safety hazard for the second story?
I mean, if you're dumb, you're gonna jump out a window.
Do y'all remember the batting average stuff? Oh,
The batting average, yeah. It's the same as the grade, isn't it?
it's the.
Kind of.
Do you remember the formulas? Should we put them down on your review, just in case?
I got it in my journal right here, actually.
Yeah. Let me take a roll real quick. Well, that thing, so they're probably gonna call my announcements in a second. Yeah. Let me send this message out to my 4th period because they still class is still down.
In a long time, you came around and come up.
All right, so batting average and slugging average. Batting average, if you might want to just write it down here in your, I'll write it right here.
Stand for the pledges. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Honor the Texas flag. I pledge allegiance to the Texas, one state, under God, one and indivisible. Please remain standing for the moment of silence. You may be seated. Did you know you can get a job in sustainable energy, climate change research, national parks, urban planning, or atmospheric space science with a geography degree? Come check out the Texas State Geography Student and Faculty Q&A panel sponsored by Women in STEM on Thursday during advisory. Check out our Twitter at Logo Women in STEM for Zoom link and more info. Everyone is welcome. Is Santa bringing you a new phone, tablet, or laptop for Christmas? These are old electronics and let Women in STEM recycle them for you to keep them out of our landfill. We will have collection boxes starting next Christmas break. And then we won't be having announcements Tuesday through Thursday. Or Bill. Just one plan.
Yay.
Do the testing. Have a great day.
Do we have
Bye-bye.
busy schedules or do we like
Yeah.
still?
Wait,
Can we do the thing that we did like?
Friday, don't forget, I forgot to mention this at the beginning of class. Friday's an all virtual day. Okay. So I'm still going to have class, but you just have to log into Zoom at home. Because it's going to be the same. I'm going to do it with my A-Day people on Thursday, start the new unit. I'm going to do it on Friday too, but it's going to be all digital. Okay. All digital. Okay. It'll be an easy one to start out. The new unit. Hits. Anytime that you hit the ball and get on base. S stands for single. If you get hit the ball, you get the first place. If you hit the ball, hit the second base is a double. If you hit the ball and you get the third base, it's a triple. If you hit the ball and you get all the way around or hit it out of the park, it's a home run. For those of you that don't know baseball, at bat is every time you come up to bat. So a batting average just adds up all of your hits together and divides them by the number of at bats. But your slugging average puts weight onto where you end up on base. Slugging average is a little bit better representation of the batter because it tells me I know that if you hit more home runs than if you hit singles, obviously they should be worth more because home runs are much better than just getting to first base every time. Okay, so these are some of the basic statistics we look at in baseball. Question number 11 says, find the batting average and slugging average for Bryce Harper. In 2012, he had 144 singles, 26 doubles, 9 triples, and 22 home runs. So first, we need to figure out how many hits he had. So I need to add up all of those numbers. So 144 plus 26 plus 9 plus how many home runs? 22. All of those are hits. So add them all up and figure out how many hits he had. And then we can find his batting average pretty easily. $201. So he had 201 hits. So to find his batting average, I take 201 and I divide it by how many at-bats he had. He had 533 at-bats. I divide them and I leave the answer as a decimal. But if you remember from this assignment, you round it to 3 decimal places. Okay, 3 decimal places, that's how we round these.
And that's 0.377.
0.377. All right, so there's the first answer. 0.377 is his batting average. For his slugging average, we need to plug in all the numbers and weight them. So 1 times 144 plus 2 times 26 plus 3 times 9 plus 4 times 22. And we're still going to divide all of that by 533.
Yeah.
Now, again, if you guys are using your cell phone calculators, why don't you figure out what's on the top first, and then we'll write one extra step, and then we'll figure out what's on the bottom, or divide it after that. So tell me what the top part is first.
311.
311? We should have gotten 311 for the top. Now divide those and round it to 3 decimal places as well.
583.
0.583?
Or 6. No, yeah, it's 5.
Is that right? You got the same thing as Dora?
Oh, I haven't done that yet.
Okay. .583. Did you guys get that at home? Good. Now, since 12 goes with this question, we can go ahead and do that one right now as well. Look at all these free points I'm giving you guys just for being here and going. Okay. A baseball player, it tells him 37 singles, 16 doubles, and 3 triples, and then 247 at bats. It says how many home runs would he need to have a slugging average greater than 4? So again, we're going to 0.400. Again, we're going to use X instead of the home runs. We don't know what X is. So let's set up what we do know. We know that he has 37 singles. So I'm going to do 1 times 37. We know that he has 16 doubles. So 2 times 16. We know that he has 3 triples. So 3 times 3. We just don't know how many home runs. So I'm going to put 4x. Okay. We know it's worth 4. They're worth 4 points. I'm going to divide all this by 247, which is the number of at-bats according to the question on number 12. But in order to solve for x, I have to make this into an equation or inequality. It says how many home runs would he need to have a slugging average greater than 0.400? So let's just put this greater than 0.400. Now we can use the equal sign too, but greater than is really what it's asking. So first step, let's simplify as much as possible. Figure out what this is in the calculator. We can just type all that into the calculator to simplify as much as possible. So figure out what that value is, and then we'll write the next step. $78. So 78 plus 4x over 247 has to be greater than 0.400. Already it's much simpler. How do I need to get the 4x out of this fraction. Right now it's being all divided by 247. What's the opposite of that? Multiply by 247. So I'm going to take 247, I'm going to multiply here, and I'm going to take 247 and multiply over here. And we do it to both sides, it's fine. This cancels out. And this gives me 78 plus 4x is greater than something.
98.8.
98.8?
Yes.
Next step. I think you guys can figure this out. I'm going to go through it pretty quickly. Subtract 78 from both sides. So 4x is greater than 20.8. And then divide by 4. X has to be greater than
5.2.
5.2. So here's a little dilemma here. This is talking about home runs. Okay, I obviously can't hit 5.2 home runs. Which way do I round?
5 down.
Normal rounding rules say this rounds down to 5, right? But we need to answer the question. It says, how many home runs do I need to get it greater than 0.400? If I round this down to 5, I'm missing that 0.2 that I really need to get to 0.400. So in this particular case, I have to actually round up to 6 as my final answer. 6 home runs. And again, because I can't get 0.52, and in order to answer the question, I've got to round up. Okay, I've got to round up. The same would have applied to that problem earlier we did the final exam. If we got 70.1, well, we can't round down to 70 because we're missing that 0.1. So we need to round that up to 71. Okay, same thing here. We got to round it up in order to answer the question. Okay, so just be careful with a problem like that. All right, we've been going for almost an hour here.
Just keep on trucking.
But everything that we've done after this has been stuff that we've done more recently. I think maybe we can do like maybe two more. Do you want to do the quarterback one? Number 16. 14 you can find in your notes. You go back in the video. 15 find in your notes. And it's in the recording. Do we want to do 16 and then probably 18?
But 16 and 18.
Okay. The check digit stuff we did last week. You guys can just do that on your own. I'll post the answers to it a little bit later, so you can check your work. Okay. Okay. I'll just do two more. 16. 16. You might want to have your notes somewhere around when you do a problem like this, so that you have the formula. It says find Steve McNair's quarterback rating in 1999 when he led Tennessee Titans to the Super Bowl. 187 of 331 pass attempts for 2,179 yards and 12 touchdowns with 8 interceptions. Okay. There's 4 statistics, if you go back and look at your notes, that we have to find before we can plug it into the formula. The first one is the percent completion. The second one is the percent touchdowns. And then the percent interceptions. Actually, I'll just put it all right. Percent interceptions. And then the average yards per attempt. And it's not a percentage. If you remember, we find each of these statistics and we divide them all by the number of attempts. Okay, it's all per attempt. So how many attempts were there? 331. Okay. So completions, I'm going to take 187 and divide it by 331. And since it's a percentage, I want it in a percentage, I multiply by 100. So let's figure out what that is and round to the nearest tenth, 1 decimal place.
56.5.
56.5?
Well, I rounded to 56.49.
Yeah. So 56.5. Touchdowns per attempt. So how many touchdowns? 12. So this is going to be 12 divided by 331 times 100. And figure out what that is. 3.62, so just 3.6. Okay. We just want 1 decimal place on these. 3.6. Percent interception, so 8 interceptions per attempt. So this is 8 divided by 331 times 100. Figure out what that is.
2.4.
2.4. And the last one is yards per attempt. 2,000 what? 179 divided by 331. What are we not going to do this time?
Not divided by.
Not multiplied by 100. It's not a percentage. It's just an average.
6.6.
6.6.
Yes, sir.
Okay. You might want to, if you don't have it in your notes, or if you don't have it on here, you can write the formula right on your paper so that you can use it. Here's the formula for quarterback rating. 25 plus 10 times percent completion plus 40 times percent touchdown plus 50 times the yards minus 50 times the percent interception. Okay. And then all that is divided by 12. So that's the formula. I'm going to put QR. Write the formula down on your review, especially if you want to use the review for the test. That way you can kind of have it all in one place instead of having a bunch of different assignments out. All right, so let's start plugging in. 25 plus 10 times 56.5 plus 40 times 3.6 plus 50 times, it's the 6.6. Be careful because it's kind of in a different order there. I saved the subtraction for last. Interceptions are obviously bad. You want to throw interceptions. Oops. That's 2.4.
I got 78.7.
So let's do this. Can you do this in 2 steps for me?
Yeah.
Figure out what the top is first.
944.
944. I'll wait till somebody else also confirms that. Guys, figure, especially you guys at home doing your cell phone calculator, do the top part first and then divide by 12. Or do it in 2 extra steps. Multiply all these out, write them down if you need to, but you make sure that you don't mess up. Remember, if you get a really, really big number, it's going to be wrong. Like the highest is 158.3. So making yourself a note if you need to. It's never going to go above 158.3. What'd you get for the top, Isadora? Same thing? 944? Okay. So all the top equals 944. You divide it by 12, and then just round to the nearest tenth, 1 decimal place.
78.6.
That's what you said too, right? Okay. So 78.6. It's actually a pretty low quarterback rating compared to a lot of quarterbacks today. I mean, Aaron Rodgers has like a career quarterback rating of like 99 or maybe a little over 100.
Oh, yeah, I just did that one last night.
Oh, you did that one? Yeah. Okay, I'm going to do one more. I'll do number 18 because the check digit ones we just did last week. You guys have that fresh in your notes, step by step. I'll post an answer key to them a little bit later today. Because 8A is taking the test tomorrow. They did this on Friday. Okay. All right, last question. Number 18 that I'm going to do with you guys. Number 18 is a Fermi problem. Okay, it's a mini Fermi problem. You guys were supposed to have done this on your own on your project. This one says how many golf balls can fit inside a fleet of 18-wheelers. It talks about some assumptions. There are 215 18-wheelers in a fleet. The 18-wheelers would be empty, so there was nothing inside them. We're going to fill them all up. We're going to fill them from the bottom to the top of the 18-wheeler. We found the dimensions of a cargo area of an 18-wheeler is 45 feet long by 8 feet wide by 9 feet tall. And there's 189 golf balls that can fit inside a small box measuring 3 by 2 by 4 feet tall. Okay. Why don't we draw a diagram? Okay. Draw a diagram of the, here's my 18-wheeler, my crappy 18-wheeler. U-Haul. I don't know. Can you spell U-Haul? Okay. There's my 18-wheeler. And I know that it is 45 feet long. So this is 45 feet. It is 8 feet wide and 9 feet tall. Okay. So that's something I already know about the. And then I can make a little box. This is my box of golf balls. I know that this box is not to scale, obviously, but 3 by 2 by 4 feet. Doesn't really matter where you put these. 3 feet, 2 feet, 4 feet. And I know that there's 189 golf balls that can fit in there. So walk me through what you think like a good process to approach this problem. I want to figure out how many golf balls fit in an entire fleet of these 18-wheelers. Well, first I want to figure out how many of these golf balls can fit in one 18-wheeler. What do you think I should? What should be my approach? Don't tell me exactly. Don't tell me what to multiply, but
I don't know. Figure out how many balls fit in that box.
I already did.
Oh, yeah.
189 already fit in this box. So I need to think bigger. I need to figure out how many balls can fit in, how many boxes can fit into the truck, right? So not diameter. Let's find the volume of the box. Okay. So let's find the volume of the box first.
Oh, diameter is for circles, right?
Yeah. Volume of the box. How do I find the volume of the box?
You add the two different sides.
Length times width times height. So 3 times 4 times 2. That's the volume of the box. Four times 3 is 12, times 2 is 24. So this is 24 feet cubed. It's a cube now. Not squared, but cubed. I also want to find the volume of the truck. I can do the same thing. So length 45 times width is 8 times height is 9, and that'll give me the volume of the truck. Figure out what that is.
Um, 3,240.
3,240 feet cubed. So, what do I want to do now? How do I figure out how many boxes can fit in one truck?
You're going to divide that volume of boxes and then
Volume of the truck divided by
volume of boxes.
volume of the box. So let's divide those two here. 3,240 divided by 24. 135. So 135, I'm going to label this, boxes per truck. Does all that sound right so far? Okay. So I know that 135 boxes can fit in one truck. My Fermi problem asks how many golf balls can fit inside a fleet of 18-wheelers. Well, there's 189 golf balls per box. There's 135 boxes per truck. And the problem says there's 215 18-wheelers in a fleet.
You should multiply it by 215.
Multiply what?
135.
So
Boxes per truck.
135 per truck times 215 trucks times what?
Times 200. Oh, wait.
What am I missing here?
Number of golf balls.
The number of golf balls per box.
Oh.
Yeah, I'm going to put that out here in front. 189 golf balls per box times 135 boxes per truck times 215 trucks. This should give me my good estimate to this problem. It's going to be a big number.
$548,000. Oh no, that's 5,000,000.
5,000,000.
485,000.
485,000.
725.
725 golf balls. It's a lot.
Big sack of Molly golf balls. Big sack of Molly golf balls.
Is that a song or something?
Yeah, it's his mom.
Really?
Big sack of motherfuckers.
All right. And there's the last problem that I'm going to do.
Damn.
All right.